Hey, Mr. Richards here. Today's 8th grade Unit 7, Lesson 15, Anchor Problems. And I'm just going to jump right to the formula of the sphere here. And it is really cool to see how it's derived. But the volume formula for any sphere, the volume of a sphere can be found by taking 4/3 times pi times the radius cubed. All right. It's a cool video, but we're just going to skip it for now and use the formula to solve a whole bunch of problems. A cylinder has a diameter of 16 inches and a height of 14 inches. What is the volume of the largest sphere that will fit inside the container? Well, that's not exciting. The height is 14 inches, which means the 16 is irrelevant to me here because the highest sphere you can have here would be 14 inches. That would be the diameter. The radius then would be 7 inches. And so we're going to say volume is going to equal 4/3 times pi times the radius to the third power. And so volume is going to be 4/3 times pi times 7 to the third power. And this is not squaring a number, it's to the third power now. And so in our calculators, we'll go 7 to the third power is 343. At this point, I'm going to put in the decimal form of pi, so 3.14 times 343. Be careful not to mix decimal points with multiplications, just be aware of what you're writing down. Now, 4/3 can be a kind of a complicated thing to write in a calculator. It's 1.333333. And depending on the level of calculator you have, sometimes it's easy to type in 4/3, sometimes it's not. If it's not, take your 3.14, multiply it by that 343, multiply it by 4, and make it equal that number, 4,308 8/800. Once you have that, multiply or divide that now by 3. Because that would, multiplying by the 4 and then dividing by 3 will get you an answer that's the same thing as multiplying by 4/3. So our volume is 1,436. And if we look to the hundredths place here, the 6 is going to round the 2 up. So 3/100ths, this is inches cubed. And the reason for using, again, the 14 instead of the 16 was if it's 14 high, I can't get something that's not going to stick up, right? Now, what happens if we have to work backwards? And that's a good question to conclude on. The volume is 288 pi cubic centimeters. What's the radius? Use your formula and solve what you know. Volume is 4/3 pi r cubed. Your volume is 288 pi, don't simplify that, is equal to 4/3 times pi times radius cubed, and that radius cubed is what you're solving for. Step 1, divide by pi. Why? Cancels out on the right, cancels out on the left. It's kind of convenient. So you're left with 288 is equal to 4/3 radius squared. Now I get rid of the 4/3, multiply by the reciprocal of 4/3 on both sides. Multiply by 3/4 on both sides. That way that cancels out. Now remember, 3/4 is equal to 7,500. So those of you who don't have a great calculator, speaking of which, I'm not sure where mine went, so we'll just type it in over here. 288 times 0.75, the 3/4 is going to be 216. So 216 is equal to r to the third power. When I take the square root, I mean not square root, cubed root of both sides. Some of you may have that on your calculators. Those of you who don't, let me tell you, taking the cubed root of 216 is the same thing as going 216 to the 1/3 power. And so that's actually how I'm going to use my calculator here. I'm going to say 216 to the 1/3 power and figure out what that is, and that is 6. So 6 is my radius, in this case, centimeters. And why is that 6? Well, 6 times 6 times 6 is 6 to the third, and that is 216. That's it for this lesson. It's basically using a formula. Can you use volume equals 4/3 pi r cubed to solve for the volume of spheres? Make sure you're using the radius. And then can you work questions backwards? If you're given the volume, define that missing radius and sometimes diameter. Good luck.